So if you do miss any of these lectures on Monday, Tuesday, or Wednesday, then I will post them for you. So did we have any questions or anything before we get started? We got a couple more minutes. And then also, don't forget, if you haven't done it already, to do the 3 requirements to be marked as a show in this class. I'm going to go through and update all of my classes after we get off of this lecture. But the 3 requirements that you need to do to be marked as a show is do the syllabus quiz. The syllabus quiz is on Moodle. And you need to send me an introduction email. All of the directions are on the where to begin document. So I'm going to share that with y'all. The where to begin document is in your Moodle. It's on the getting started tab. And it's that very first document under that red bar. So these are your 3 requirements. Can y'all see this
We can.
document? Did it pop up?
It's still on the notes.
It's still in the let me see. Let me fix it to there we go. Okay. So the 3 items that you need to complete, it just has the first one is your syllabus quiz. A lot of y'all have already done that. The syllabus quiz is due, I believe, September 13th. So not this Sunday, but next Sunday. And you'll find that like all of your homework is due on a Sunday at midnight. The only homework that's not due on a Sunday at midnight is the chapter 8. That's the one that is due like around the midterm, and that's due like that Thursday night. But all of your due dates and everything are on your calendar, so just utilize your calendar. The second requirement, email me an introduction, just a couple things that I need you to put in there, what course it is, your name, if you prefer a different name, stuff like that, what campus you're on. And then lastly, just you need to set up an account in MyMathLab and get registered in MyMathLab. So you'll use this link right here for MyMathLab. If you have any questions, please stay after the lecture and I can help you get into it. If you have problems with getting an access code through the Red Shelf link, just hang around after the lecture and we'll make sure everybody gets in. So I guess we're going to go ahead and get started. The notes, so if you click on the chapter, so it's Unit 1, Chapter 2, Set Theory, and you'll have to scroll down, and here's all the notes. So you can print them to go along with the lecture if you want. Like I said, the Word document is they don't have any answers on it. It's blank. This is the same thing that we would give you in class. So if you print it off, it's really helpful. You can put it in your notebook or wherever you want to put it. So this is pretty much everything that's on those notes. It's just condensed down to where I could fit it all on one page. So if you're ready to get started, we'll just go ahead and get started. We're just doing section 2.1 today. It'll be pretty short. It probably will probably be done in like 30 minutes. So if we don't have any questions, then I'll go ahead and get started. Alrighty. So, chapter 2 is over set theory. So, set theory is something that they use in like higher level mathematics, and they use it like in everyday life. So, sets. A set is a collection of objects whose contents can be clearly determined. That's the definition that they use. I have put all of our definitions up top. So a set or a collection pretty much is like a category. So an example of how they use sets in everyday life is whenever you're filling out like an application on something, you have to put like your gender, you have to put your age and stuff like that. And they take that information and they will put you into a certain category or a collection. So say you're applying for a job and they want to hire someone, they want to hire like a female that's between the age of 25 to 30 or something like that. They use these collections or categories to find the person that they want to hire. So just think of it that way. It's a set is kind of like a category. The elements are just the objects that are in our set. So there's a couple ways that you can represent a set. There is the roster method, and then there is set builder notation. So roster method is kind of the easier way to represent a set. There are a couple requirements for the roster method. You need, first of all, to put everything that's in your set in these braces or brackets. So on your keyboard, it's right next to the letter P. So it's those funky looking squiggly braces. And you would also need commas to separate all of your elements. So those are the two main requirements that you need for roster method. And then set builder notation, and this definition is not on your handout, but I just put it up here. It's just a mathematical notation for describing sets. So like I said, they use sets in higher level mathematics, and they use the set builder notation basically to describe what's going on in the set. So our roster method, we actually list everything out, and the set builder notation we describe, or we put some type of condition on. So I'm going to bring this over here. And if you printed off the Word document, or if you're looking at the Word document, it has this like in the middle of the first page. And I'm going to kind of go over how this reads. I know that it's weird looking, but the way that it reads is that our set W, I might not have enough room. So our set W is the set of, and then we have all elements X. And then this line right here going up and down means such that. So this is like the way that you would read this set builder notation. But basically what we're looking at is our condition. Our condition is at the end. So X is a day of the week. That's all that we care about. All that we care about is that X is a day of the week. So that's what this set is. So if we were to write this set W, and they always are going to name your set with a capital letter. So if we were to write our set W using our roster method, all we're doing is listing out the days of the week, Sunday, Monday, all the way to Saturday. Are y'all good with everything? Alrighty. So the main thing that you're looking at whenever you see the set in set builder notation is whatever your condition is. And that's always going to be at the end. And they will give you multiple conditions. So it could be more than one condition that you're looking for. So some other definitions that we'll go over: the empty set. The empty set is exactly what it is. It's a set that is empty. It has no elements in there. I know that sounds weird, but say that they give us some type of condition that cannot be met, then the set is empty. So whenever you have an empty set, you would represent it with either empty brackets, so just our brackets with nothing in them, or you would represent it with the 0 and the line through it. You cannot use both. So anytime you see this or this, just know that you are looking at the empty set. Our natural numbers. So our natural numbers are just our counting numbers. So if you look down at our exercises, they will use this n, or our natural number, a lot in this chapter. All that means is that we're looking at positive numbers. So our counting numbers, we start at 1, 1, 2, 3, all the way into infinity. We don't start at 0, and we don't count with negative numbers. So anytime you see that they give you something like this, it means that x is an element of the natural numbers. All that means is that x is positive. So don't let that confuse you. All it means is that we're looking at our counting numbers. Any questions on that one? All right. And then the last definition that we're looking at is our cardinal number. Our cardinal number is just the number of elements in a set. So if you look down here, it tells us how to represent a cardinal number. So whatever your set is named, it goes in the parentheses. So if we're looking at our set W that we just looked at with the days of the week, our cardinal number of this set would be 7. All you're going to do is count the number of elements. All right, I know it's a lot already, but we'll go through the exercises and it'll kind of help with everything that we just went over. I always like to go over the definitions and kind of put like a foundation first, and then always work through the exercises after that. If y'all have any questions, just stop me. So exercise 1, we're going to look at A. Exercise 1 says to express the set using the roster method. So our roster method, remember, we have to have the braces and we have to separate all of our elements with a comma. So our first one is A, and it says we have the set of odd natural numbers less than 13. So we have a couple of conditions here. We have that we're looking at the odd numbers. We have that we're looking at our natural numbers, so we know we're not going to have any negative numbers. And then we have that we want less than 13. So they did not name the set. I'm just going to name it A since we're on letter A. And we have A equals, and we have our braces. So we have the set of odd natural numbers less than 13. Okay, so we're only looking at our odd numbers. What number are we going to start with? We'll start with 1 because we're only looking at our positive numbers. We're not going to use any of the even numbers. So we're going to skip over 2, 4, 6, and all that good stuff. So we have 1, 3, 5, 7, 9, and we know that we're going to be less than 13. So less than 13, we're going to stop at 11. We cannot count 13 because 13 is not less than itself. So if you need a review on less than, and equal to, and all that good stuff, let me know and we can do a little review after the lecture. But just know that whenever they say less than, we have to look less than that number. We can't count that same number. So our set for letter A would just be the numbers 1, 3, 5, 7, 9, and 11. Is everybody okay with this one?
I have one question.
All righty.
Do you always have to name the set? Because you named it A equals and then you put the...
No, you don't have to name the set. And whenever you are doing your homework, they'll just, I think they give you the braces already, and then they'll have like a box, and all you're doing is putting the elements in that box. But no, you don't have to name a set. I just always name them. Alrighty, so B, we have that. So we have our set builder notation. But our main conditions that we're looking at is that X is a natural number and that X is less than or equal to 5. So when we have that X is less than or equal to 5, we are going to include that number 5 because it has our equal sign underneath it, because 5 is equal to 5. So we know that we're looking at our positive numbers, our counting numbers. So we're starting at 1 again, and we're going to 5. And we are stopping at 5. So our set for B would just be the numbers 1, 2, 3, 4, and 5. Alrighty, C. I'm not going to name this one for you, Nathan. So C says that we have our natural numbers again, and now they put X between two numbers. So we have X between 6 and we have X between 10. So I'm going to actually rewrite this for y'all. Anytime they give it to you with X between two numbers, so we have X less than, or we have 6 less than X, and then less than or equal to 10, we can take this first piece and flip it. So whenever you learn about less than, greater than, all that good stuff, like I learned it as like the alligator mouth. So whatever way that your alligator is facing, our alligator is open to our X, so it has to stay open to the X. So if we mirror it, then we would have X is greater than 6. Our alligator is still open to our X. We have to keep it going that way. So we've now created our two conditions, that X is greater than 6 and X is less than or equal to 10.
Real quick, why would you change it around to put X in front?
It's so some people get confused whenever X is in the middle like this. So to stop the confusion, if you break it apart like this, you can see, okay, X is greater than 6 and it's less than or equal to 10. So just to make it easier on some people who get confused, you don't have to do it. If you understand what's going on right here, then leave it like that.
Okay, perfect. Thank you.
You're welcome. But a lot of people haven't seen stuff like this in a long time. So when I break it apart like this, light bulbs go off. So it's helpful. It's helpful for some. If it's not helpful for you, then leave it how it is. So, all right. So we have X is greater than 6. So we know that we cannot include 6 because 6 is not greater than itself. So we're going to be starting at 7. So we have 7, 8, 9, and then x is less than or equal to 10. So we know we're stopping at 10 because we have our equal to sign. We are including our 10. So C, our set would just be 7, 8, 9, 10. Alrighty, D. D, we have our condition that x plus 5 equals 7. So don't get confused on this one. Just think about it. What number plus 5 equals 7? And the only number that we can put in our set is the number 2. All right, and then our last one on number 1, let me put a 1 right here. Our last one on number 1, our conditions are that x is a natural number and then x is between 15 and 60. So I guess I'll stick with the red. So we have 15 is less than or equal to x and then less than 60. So we have less than or equal to, and if y'all want me to leave it like this, I will. If you want me to break it apart, if that's helpful, let me know. So x is greater than or equal to 15. So since we have that equal to, we're going to start with our 15. And we're going to be going all the way to 60. But can we include 60 in this set?
No.
No, because x is less than 60, so we're going to go all the way, and our last number is going to be 59. So in this one, it's a lot easier to use the set builder notation because you're not listing out 40-something numbers or however many numbers that is. All right, any questions on number 1?
I have a
If
question.
that went around, how would it look?
I'm sorry? Mikey, what'd you say?
If you switch that one around, like how we did on the previous one, where you switched like the greater than 10 on x. Yeah.
So it would look like this. X is greater than or equal to 15. So just remember, whichever way your alligator mouth is open to, that it has to stay open. So it's open to the X over here. It has to stay open to the X over here.
Okay. Thank you.
So we have X is greater than or equal to 15, and we have X is less than 60. And then did somebody else have a question?
Yes, ma'am.
I did.
Cardinal number. So like it's like so it's like every number that's in that set.
When in roster method?
No, like the cardinal number, like you know how you have like Monday and like Sunday through Saturday? It's like it's everything that's in that set.
The cardinal number, all you're doing is counting the number of elements that are in that set.
That's what I was trying to
So
say.
we'll get down to that one on number 3. We'll do the cardinal number.
Okay.
And then Eric, I think you had a question too. What was your question?
My question was, hold up, sorry, I went blank. Oh, will there ever be multiple conditions? Like maybe A and B would be all included into one question?
So like multiple sets in one question?
Yes.
No. Well, yeah, we'll have multiple sets that we'll be working with, but in this first section, you're just going to be looking at one set.
Okay.
Alrighty. Good questions. I'm glad y'all are asking them. Any more questions before we go on to number 2?
You kind of lost me on E. I don't know. I walked away and I came back and I saw you doing it. I didn't know what I did.
At what part?
On E, the last part.
On E?
Yeah.
Okay. So E, these are our 2 conditions. And we have that X is between 15 and 60.
Yeah.
So we broke it apart kind of like we did over here on that other one. And remember, whichever way your alligator mouth is going, it has to stay facing the same part. So since it's open to the X, whenever we flip it, it has to stay open to our X. So we have that X is greater than or equal to 15, and it's less than 60. So I just put these 3 dots instead of listing out all the numbers. 15,
Oh, okay.
16,
That's what I was. Okay, I was confused. I was like, how'd you just get 15, 16, and 59?
Oh, no. So those 3 dots means that it just keeps going, and then we stop at 59.
All right. Thank you.
You're welcome. All right, everybody else good?
So there can only be one notation per, I guess, equation, or I guess per formula.
So they're going to tell you express the set using the roster method. They're not going to ask you to put it into set builder notation.
Okay.
They're just only going to ask you to put it into roster method. And remember, the roster method, just as long as you remember your requirements that you need the brackets and the commas, you'll be good. All righty, number 2. I guess I'll start it right here. So number 2 says determine if the set is the empty set. So remember, a set can be empty if it has nothing inside. So no elements. If there's no elements, then it's an empty set. All right, our first one, A, says that, so this is, they're going to give us our set builder notation. I'm not going to read it all out for you. We're just going to only look at our conditions. So our conditions, we have that X is less than 2 and X is greater than 5. So we have X is less than 2 and X is greater than 5. So I'm actually just going to draw a number line for you real quick so we can see what's going on. We have our numbers all the way to 5. So our first condition says that X is less than 2. So if it's less than 2, I don't know if you remember drawing these on the number line, but if it's less than, we're going to the left. We want all those numbers. And we're not including 2, so we don't fill in our circle on 2. And then we have that X is greater than 5. So X is greater than 5 means we're going to the right of 5. And again, we're not including 5. So this set is actually empty because there cannot be a number that is both less than 2 and greater than 5. So this is our empty set. Everybody good with that? All right.
Yes, ma'am.
B, it's kind of the same thing. They tell us that X is less than 3 and X is greater than 7. So again, we have an empty set because you cannot have a number that is less than 3 and greater than 7. It just doesn't work out that way. So B is also empty. Alrighty, letter C, we have that X is a natural number, so we know we're looking at our positive numbers. And then we have that X is between 2 and 5. So if I draw our number line, we have 1, 2, 3, 4, and 5. We have X is, where are we at? Oh, we're down here. So X is greater than 2. So all I'm doing is flipping it around. And we have that it's less than 5. So we have these numbers right here. So this set is not empty because we have 3 and 4 that's in our set. So I'm just going to put not empty. Alrighty. D. Same thing with D. It's not empty because X is between 3 and 7. So we have numbers that are in our set. So I'm not going to draw the number line. I'm just going to put not empty. Is everyone good with that? Alrighty, and then the last one, E, and I don't think I added this one to your notes. This is just something to think about. I think they have an example like this on your My Math Lab homework. So it says that X is a square with exactly 3 sides. So can a square have 3 sides?
No.
The square always has 4 sides, so this is not possible. This one's empty. Alrighty. What color do I want to use next? I guess I'll use like orange. Alright, so now we're on to our cardinal number. Remember, our cardinal number, all we're doing is counting the number of elements that are in that set. So, let's do right here. So, A, we have the set S equals, so it looks like we have our even numbers 2, 4, 6, all the way until 30. So whenever we represent the cardinal number, remember we're going to use this little n and then the parentheses, and then whatever the name of our set is going to go inside of our parentheses. So on letter A, our set is named S. So to represent the cardinal number, we would put n of S. That's how you would say it, n of S equals. So what would our cardinal number be for this set? The
15.
easiest way, yes, thank you, whoever said that. The easiest way to look at this is if you know that if you're counting 1, 2, 3 all the way to 30, we know that that's 30 numbers. We're only looking at the even numbers, so we're only looking at half of those numbers. So yes, our cardinal number would be 15. I think, Matthew, is that you that said that? Thank you.
Yeah. You're welcome.
All righty. B, we have our set W. Okay, so we named our set W. We're looking for the cardinal number, and it says that our set is X is a letter in the word 5. So if we're only looking at the letters that are in the word 5, how many elements do we have?
4.
4. Yes, we're only looking at these letters, F, I, V, E. So we would have 4. And if we were to write that, I'm going to try and write it out. This is what our set would look like in roster method. It would just be our letters F, I, V, E. Alrighty, and then our last one is C, and we have our set G. So our conditions say that X is a natural number, and then we have that X is between 2 and 7. So I'm going to go up here, and we're going to rewrite. So we have 2 less than or equal to X, and then less than 7. So I'm going to rewrite this. We're going to break it apart. So our alligator, our first alligator is open to our X. So we have that X is greater than or equal to 2. And we have that X is less than 7. So if we were to write our set in roster method, we would include 2 because we have our equal to sign. So we have 2, 3, 4, 5, and 6. Are we going to include 7?
No.
No.
So we're not going to include 7 because X is less than 7. So 6 would be our last number. So our cardinal number for this set is 5. Is everybody okay with this?
Yes, ma'am.
Alrighty. Our last one is number 4. So 4 says to determine whether each statement is true or false. So I kind of briefly went over this funky looking E. So if you look at your notations and formulas on the first page of your notes, it tells us that so our regular E without the line through it, it means that an object is an element of a set. And then whenever they put the line through it, it just means that it's not an element of a set. So if we were looking at our first set that we started with, where W, the set W was all the days of the week. Let's say we have like August. August is not an element of our set W. So that's kind of how that works. If we look at like Sunday, we see that Sunday is an element of our set W. So this E just means it's an element of. So we're going to determine whether each statement is true or false on number 4. On A, it says that 3 is an element of the set 1, 3, 5, 7. So I'm going to write this one out for us. 1, 3, 5, 7. So is 3 an element of this set?
Yes, ma'am.
Yes.
Yes, so true. Not too hard. All right. B, we have that 5 is an element of the set 2, 4, 6, all the way to 30.
No, ma'am.
So that is false because we're only looking at our even numbers. 5 is not an even number, so it's false. Alrighty, C, we have that 11 is not an element of the set of numbers 1, 2, 3, all the way into 9. Oh, let me put the line through it. So 11 is not an element of this set. So yeah, it's not an element. So this statement is true. Is everyone okay with that?
Yes, ma'am.
All righty. And then our last one, we have that 37 is not an element of the set 1, 2, 3, all the way to 40. So is 37 an element of this set?
Yes, ma'am.
Yes, ma'am.
It is. So this is false. All right. Any questions on this?
I do have a question. Back on number 2E, if it
Yeah.
the square had all 4 sides, would it be I guess not empty?
Yeah, so if it said that X is a square with exactly 4 sides, then it would not be empty.
Okay, thank you.
You're welcome.
I have a question regarding the cardinal numbers, if you don't mind.
Yes, sir.
So, like on C, you're basically looking for a cardinal number between 2 and 6. My question is, why 5? Why not 4? I just don't understand, I guess, where that's coming from. Or like on A, all the numbers are even, so why is it an odd number that is a cardinal number?
That's just what they decided for that set. So they're asking us, they gave us what the set is, and it's not our job to figure out what's in it. We're just counting the elements that are in that set. So they're going to give you a set, and then they're going to say, like, what's the number of the set.
Okay, I got it. That was the missing information.
Yeah.
All right. Yep.
I know it's kind of small, but I had to fit it all onto this one page somehow. So if the notes off, it's a lot easier to go along with.
Yeah, I mean, I got them.
Okay. All right. Any more questions? So this homework is not due. You have a couple weeks before it's due. I think the due date for all of chapter 2 stuff is not until September 20th. So you have quite a bit of time to work on this. So I mean, if you just work on it like one section at a time, it'll go by a lot better.
All we have to do for this week is the syllabus quiz, right? And then the email to you.
Yes, sir.
All right, just making sure.
Yeah, and if you want to go ahead and do the homework for this one on my math lab, go for it. And I mean, all of your assignments should be on there. I made them all available on the first day, so if you do want to work ahead, you can. And if you can't find the assignments, there's like an assignments tab that you have to click on, and then they should all pop up.
Ms. Christie?
Yes, sir.
So I have two questions. One is on the calendar, it doesn't say that you'll like be teaching 2.5.
Let me see. Yeah, it's not until September 14th. So a couple more weeks. So
Yeah, and we're supposed to take the test from 2.5, like from 2.1 all the way to 2.5. So do we just like go ahead?
if you want to work ahead, you can, but none of this is due until September 20th. So we have this week, and then next week, and then the next week after that to work on all of this. So I will do 2.5 that Monday, the 14th. And then I'll do like a short little review on that Tuesday. And then everything will be due that Sunday, the 20th. So you have plenty of time to work on everything.
Okay, and also for the math question, I didn't really understand the cardinal concept.
Okay. So all you're doing on the cardinal number is just counting the elements, the number of elements that are in that set. So the first set that we talked about in the very beginning was our set W. Let me scroll down. So they told us that like W was like all of the days of the week. So like Sunday, Monday, all the way to Saturday. And if they were to ask you what is the cardinal number of this set, you would represent it first off with a little n, and then you'd put the name of your set in the parentheses. And then all you're doing is just counting the number of elements that are in that set. So we know that there's 7 days in a week. So our cardinal number is just 7. So all we're doing is just counting the elements. Did that answer your question, or what was are you still kind of confused?
That answered my that helped me understand it a little better. I guess the part that confused me was part A, when we found out that the answer was 15.
Okay. So so I'm gonna use like a brown so it tells us that it's named S. So it tells us on A that S equals the numbers 2, 4, 6, and I'll just write them all out so we can see what's going on. So whenever they put those dots, it just means that the numbers continue on. They just put the dots so that we don't have to write them all out. 22, 24, 26, 28, and then 30. So if it confuses you how we did it, then you can write it out and just count all of them. But the way that I explained it was that if we're looking at the numbers, if we're looking at all the numbers, even and odd, like 1 through 30, we have 30 numbers. If we're only looking at the even numbers, then it's half of those numbers. So half of 30 is 15. And you can actually go through and count, and that's 15 numbers that are in our set. So we would represent our cardinal number with our little n parentheses and then our set. And we have that there's 15 elements. So if you're a visual person and you want to write them out, go for it.
So I don't know if you already asked this, said this, but how is it that if we're trying to find out the set, right? Why are we trying to find out half of the first question? Like, why are we trying to find out if it's 15 and then
that's just the set that they give
and the
us.
other ones?
So if you look where my mouse is, I'm trying to circle A. They already tell us that our set S equals these numbers. And we know that we're not looking at the odd numbers because they only give us 2, 4, 6, and 30. So that's our indication that we're only looking at the even numbers. We're not looking at any odd numbers.
Oh, okay, I get it. Like we're counting the odd numbers.
Well, we're
to
only
make our
counting our even numbers. We're not counting any of the odd numbers.
I mean, we're counting our even numbers to make our cardinal number.
Yes, sir.
Okay.
So you just have to go off what they give you. They'll always tell you what your set is. And then it's your job to just, whenever they're asking the cardinal number, to just count.
So basically, the cardinal number is just how many numbers are in between the brackets, correct?
Yes. And it could be letters. I mean, we had the letters F, I, V, E, and B. So it could be letters or numbers. It just depends on whatever they give you for that set.
Yeah, I guess number, let's see, the last question on the cardinal equation C, it like threw me off because we didn't find a cardinal number. We just made the set, so that like threw me off.
Okay, so we have our set up here. I wrote the set out instead of just leaving it as like x is greater than or equal to 2 and then x is less than 7. I wanted to write our set out so we could see what's going on. But if you look down here, we did find the cardinal number was 5. I know it's kind of hard to tell what's going on. That's why I did them in different colors. But I don't have as much room as I would have like on a whiteboard. So I know it's all bunched together, but it's down here for you.
Yes, ma'am, I got it now.
Alrighty.
On a question like I guess 2A, I believe. Yeah, 2A.
Mm-hmm.
Since 2A is empty, would there be no cardinal number, or
Mhm.
would there be a way to find that too?
No, the cardinal number would be 0.
Okay.
Good question. And I,
Matt, do we have an this week for 2.1?
I'm sorry?
Do we have an assignment this week over 2.1?
Yes, so 2.1, you can go ahead and work on it. It's open on my math lab, but it's not due until September 20th. So you have some time. But I mean,
Oh.
since it's fresh on your brain, I would go ahead and work on it.
Yes, ma'am.
And
Thank
then you can always, like Thursdays, I have set up for questions. And then if you're in the AZ3 or AZ6 class, Mr. L has times as well set up. So just write down any questions you have. If you're confused on anything on my math lab, you can always shoot an email to the instructor and it'll send me an email and I can set something up with you to walk you through it or try to answer the question over the email.
Hey,
So,
Miss Christie.
yes, sir.
I just had a question. Like, I don't know if you went over it on yesterday's lecture, but over attendance, because I have a class yesterday during the lecture, so I wasn't able to join yesterday. I was just wondering if you're taking attendance for every video.
No, I'm not taking attendance. I do check and see of all the people that are here, but attendance is not part of your grade. I know that other people, like you have other obligations and some classes during the same time. So that's why I'm trying to record all of these lectures for you. And I'm going to send out a link every Wednesday that is going to have these recordings. So after we do the last lecture on Wednesday,
Okay,
then I'll
thank you.
send out a link like in an announcement, and it should go straight to your student email. So that is actually all I have for y'all today. So y'all are free to go. If you don't have any more questions, y'all are all free to go. Thank you for showing up. Bye.
Have a good.
You too.
Thank you, Ms. Christie.
All right.
You're welcome.
A quick
care,
question on that. The thing we just took all our notes on, that's going to be on the video, so we can just screenshot that, right? If I wanted to have that.